My name is Duke Skarda. I'm the Chief Technology Officer at Softlayer. This morning I want to talk about a key difference in two prevailing philosophies that drive cloud service provider architectures. So with you as a consumer of the cloud, as you begin to select service providers, this is a key differential way that we as service providers think about the products that we're delivering to you. And so I want to talk through these two philosophies and why they're important to you and how you can evaluate service providers that claim to be achieving internet scale for you. First, I want to talk a little bit about Softlayer, give you just a quick update on who we are. It's been a little while since we spoke in this region, and we've had explosive growth over the last several years. We're about 6 years old as a company from 2005. In that time, we've deployed data centers in 13 different sites across 3 continents, primarily in the United States, but also right here in Singapore, as well as in Amsterdam. We have a private backbone network, dark fiber network that connects all of our data centers, and I'll talk about why that's a really important element of our platform in a moment. In those data centers, we have over 100,000 servers now. We've got 24,000 customers, many of whom are here in Singapore and in the greater Asia area. But our platform is, while we make it obviously for our customers, the platform and the way we've developed it is really targeted at our customers' customers. So the way we have deployed our data centers, the way we've deployed our architecture is to allow you to get close to your customers. We have, just to give a final element of scale, we have over 23 million domains now managed in our infrastructure. So a great number of the internet applications and internet websites that you hit on a daily basis, iPhone applications, ultimately that data goes somewhere in our data centers in a lot of cases. So we have a really big platform, explosive growth over the last several years. So let's talk about internet scale versus enterprise class. And I'll define sort of what I mean by those two things in a moment, but let me first kind of paint a picture using a really simple scenario. So if we look at a role, the same role in 2 separate companies, the role being an email administrator. An email administrator at an enterprise versus an email administrator at an internet email hosting company or email as a service company. Same role, but 2 very different problem sets. The email administrator at the enterprise, when he goes to bed at night, he wants to wake up the next morning and know that his costs are the same, that the number of email boxes that are active the next morning are about the same number that were active yesterday, that the disk space used by those email users is about the same. His goal in life is to continually cut costs and provide just enough service for his internal users to remain happy. His great fear is that he wakes up one morning, his big failure is to wake up one morning and find that his usage, that his customers, his internal customers have, begun to use 10 times the number of disk space overnight. When he wakes up in the morning, if he has allowed that to happen and his platform has allowed that to happen, he's failed. And he walks into a little pink slip on his desk that says, you can't work here anymore. Your job was to contain costs, and you failed at that. For the email hosting company, the email as a service provider, his great dream is to wake up one morning and find that his platform overnight auto-scaled to 10 times the number of mailboxes, to 10 times the disk usage. He wakes up the next morning, comes into his desk, and finds a reward, right? He gets a bonus on the fact that his job was to successfully auto-scale to the needs of his customer base. That's just sort of philosophically, that's the difference between internet scale and enterprise class. That's where we're coming from. That's just a really simple example. One company wants to scale. They want to do it quickly and automatically. The other company is about containment. So the reason this is important is as you begin to select a service provider, you want to take into consideration what are the goals of that service provider. Cloud providers sort of generally segregate ourselves into one of two companies. Either we're targeting enterprise class customers or we're targeting internet scale customers. What this means is when we begin developing our products, we focus on one set of needs over the other. So the enterprise class cloud provider is focused on building tools that allow you to contain costs, that allow an enterprise customer to have long-term planning. These things equate to things like long-term contracts. They are focused on, lost my timekeeper here. They are focused on keeping the platform available but contained. The internet scale company, though, is focused on providing flexibility and agility and allowing you to scale overnight on a global basis. These are two very fundamentally different product development techniques, and they drive everything down to the way we build our portals, down to the architecture that we implement, and that ultimately really impacts you. Now, does that mean that an enterprise doesn't want an internet scale provider? It certainly does not. You can solve enterprise problems in an old-fashioned way with long-term planning, 3-year contracts, trying to design upfront the entire architecture, or you can solve the same problem using new techniques, using internet scale concepts, things like big data, things like auto-scaling techniques. You can solve the same problem both ways, but what the internet scale service provider allows you to do is to solve problems you previously couldn't solve for your internal customers. Whenever marketing came to you and said, we've got an idea, we think this might be a good product, but we're not real sure, we want to prototype it. And then you begin to put costs to that prototype. And those costs, if the prototype succeeded, those costs needed to be able to cover a successful product launch, right? But if it failed, that cost was all sunk. So it's perhaps millions of dollars that you had to say no to marketing on a particular product because it was a bad investment idea. You weren't sure what the outcome was going to be. With an internet scale methodology and philosophy, you start small and you grow as that product succeeds or fails. And if it fails, you simply contract it all, you move on. You don't have long-term contracts, and you don't have lock-in to an architecture. So that's a fundamental difference in cloud provider philosophy. Enterprise class versus internet scale. So when you're beginning to look at a cloud provider that claims to target internet scale companies, what are the things that you want to look at? So we're going to go through a series of topics here. I'm going to generally break them into 3 categories. The first has to do with access. Accessing your servers, your customers accessing them, servers accessing other servers to be able to interoperate with each other. Access, architectural flexibility. You want to have good flexibility in the way you define your architecture and the way it evolves over time. And then third is the ability to execute. So a cloud provider might talk about both of those things, but can they really execute? And do they give you the tools you need to execute within their platform? So those 3 categories is what we're going to go through now. So first, when you look at access, there's an outside-in view of access. This is how does the world get to your compute resources, get to your servers in your cloud provider. You want to have a network that has a global reach, that expands multiple continents, and that targets customers, your customers, in a number of different places, and allows you to get your compute resources as close as possible to those customers. You want a private network. Most cloud providers have, they may have regional distributions of data centers, but they don't have that network connecting all of those data centers together. The impact of this is that your traffic from one server to another, whenever you're either transferring files, when you're syncing across regions, when you've got data that needs to be moved from one place to another, your private traffic has to go out to the public internet from one data center to another. When you're going from Amsterdam all the way over to Singapore, that's a lot of public internet to transition. And you lose control over the security to some extent. You lose control over the performance of that network. So you want a cloud provider that automatically ties together their data centers, thus your servers, privately on a controlled network. Likewise, you want costs to be manageable within that network. On a private network like Softlayer's, we don't charge for that traffic back and forth between those data centers. That can be a significant cost savings when you're using a provider that charges you outbound and inbound traffic from one data center to another. So this is a key element of a true internet scale provider. You want data centers connected with a global reach. The second thing you want to think about is the individual server, sort of the inside-out view. How is that individual server connected to the rest of the world? There is a concept of really getting your latency low. So the Softlayer goal is to have all of our servers within about 40 milliseconds of customer traffic. We're not quite there, but we're very, very close. We now have the global reach, and we get within about 60 milliseconds of the major metropolitan areas of the world. You want to be able to have your customers very close in time. You don't care so much about geography. You care about how long does it take their signal to reach your server and make a request. Second, you want a robust and big pipe into that server and out of that server. You want to at least be able to get 10 gigabits all the way into your server. You may not need the full 10 gigabits, and that's an expensive solution, but if you're going to hit scale, you want to be able to scale up to that. Finally, we all know that IPv4 addresses are a scarce commodity these days. So you want a provider that is already prepared for where the future is going. IPv6, you want a provider that has IPv6 support all the way down to the server through all of the products, the load balancers, the firewalls, the entire infrastructure is IPv6 ready so that you're ready to scale whenever IPv4 addresses become just too expensive to be supportable anymore. And finally, you want to have multiple paths to your server. So the way we have solved this at Softlayer is each of our servers have 5 physical interfaces to the various networks we have. 2 of those interfaces go directly out to the public internet. This allows you to have multi-homed, or you can bond the NICs and have twice the throughput out to the public internet. And that's multi-homed all the way through our infrastructure. 2 of those NICs connect you to that private network that allows you to control traffic between your servers on a completely physically separate set of networks. And it's also redundant. So that way you can know that you're always going to be able to have private communications and public communications with your server. Likewise, you want to have control over those various NICs. You want to be able to turn the public NICs off for a private computer. Or if you don't need private access, you can turn the private NICs off and have a completely public computer. You want to have access and control over all of the aspects of your network. We also have a 5th NIC which allows for out-of-band management of your server. So we can reboot. Our portal allows you to control your server through that management NIC. You can also VPN, so if you've turned the public network off on your server, you can VPN directly into your server and manage it in a completely controlled manner, and the rest of the world can't even get to that server. So those are the 2 aspects of access: global, the outside-in view, and the inside-out view. You want to be able to take both of those into consideration and make sure that your service provider is solving both of those equations in the way that you need them to be solved. Second, I want to talk about architecture. It's very common in cloud provider space that there is one architecture provided to you, and that the typical architecture is an entirely virtualized server. It's a public cloud, or it's a completely private cloud, and you have to select whenever you pick a provider. The problem with that is you don't really know at the beginning exactly how big your infrastructure is going to be. You want to be able to start with what you believe the architecture to be, and then be able to change and adapt that architecture as your customers' needs change, as your needs change, and as your growth drives different scalability needs within your architecture. So there are workload requirements that are specific to each layer in your architecture that you want to be able to take into consideration. You don't want to be locked into a single architecture that a cloud provider offers. So to achieve internet scale, you want to be able to have a lot of flexibility. If we talk through kind of the main options in this arena, all of them obviously start with a physical server, and you want to have good API access into your server to be able to manage it. I think you'll provide that in just about any cloud provider out there. The things that you want to begin to really look at that really differentiate cloud providers are the different compute resources that they offer up to you. Do they offer dedicated servers? Do they also offer cloud instances so that you can have a common network across multiple types of infrastructure and build a architecture based on a combination of these compute elements? So let's take a look at how you might arrange these with a couple of different scenarios. If we look first at the database. So just about every infrastructure in the world is going to have a database associated with it. If you go with an Oracle database or a Hadoop database, the two requirements are very different. The workloads are very different. In an Oracle instance, they're going to want, an Oracle instance typically wants a big server. It's going to be fairly static. They don't auto-scale. They don't jump out and go to different servers. It's a static workload. But it wants to be set up a certain way. It doesn't really like a hypervisor. You would never really want to put that into a fully public cloud. You're going to want that on a dedicated box. And you're going to want to have SAN storage attached to that. Oracle over the years has done a very good job of optimizing for SAN storage on a dedicated server with no hypervisor. Hadoop, on the other hand, auto-scales, or it can, if you set it up correctly. It likes storage to be located right on the same box, but it needs that storage to be very fast. So in this case, a database box, you're going to need smaller boxes, multiple of them, and they're going to want SSD drives, very, very fast local storage to be on the same box. So that's two discrete examples of just a database server that have very different workloads and very different configurations that you're going to want to have. So you're going to want a provider that gives you the ability to have both of those. But whenever you get to the other end of your infrastructure, the web heads, for instance, they don't need really any local storage. They want to be able to scale very quickly on demand. Whenever load spikes, you want to be able to instantly scale out your web farm. So that's a great opportunity to put that in a public cloud. But you need to be able to have that public cloud instance, and all of them work with those two database servers that we just talked about. And then in addition to that, you're normally going to have some business servers and maybe some workflow servers. And you want to be able to pick the right compute environment for each of those various workloads so that you can solve the problem you're trying to solve with the right architecture. Not start with an architecture that a cloud provider gives you and then try to squeeze all of your workloads into that same architecture. So I'll give a quick example of one of our customers who thought they were actually an enterprise customer. It's a franchise company in the United States. They had a very standard workload, very static on their website. They sell franchises for medical services. And they had a very good infrastructure with us, and it worked quite well. But one night there's a TV program in the United States called Undercover Boss. I don't know if you guys have ever seen this. It's a really interesting show. What happens in the program is the CEO of a company joins the company sort of in an undercover way. They either disguise themselves or go work in a place where people don't know them and don't know their face. And they come into the company as a low-level worker. Maybe they're a secretary. In one case, they delivered mail. I've seen one where he was the CEO of a trash collection company, and he was a garbage man for a week. So they join the working ranks undercover. And this boss, the CEO of this company, was a part of this TV show, Undercover Boss. And during the 1 hour that show was on, everyone in the United States who was watching that show began to learn about the opportunities of this franchise company. So not only is it an interesting show, it's also a great advertisement for the companies that participate. During that 1 hour, their traffic on their website went up almost 100x. They began to get alarms, and they began to call us in a very alarmed manner and say our servers are about to go down. We were able to respond very quickly, got I think about a half dozen new cloud instances. They scaled up. That lasted for about 2 weeks while the reruns and kind of the initial onslaught of that show. And then their traffic tapered back down. When it tapered, it was about 2x what it was prior to the show. But that's a great example of being able to scale up to meet a demand, a completely unexpected demand at an enterprise, and then scale back down, meet new growth, hit a peak, and not have the server go down. You want a cloud provider that can do all of that. And this particular company has all the stuff that I just talked about. They have their database servers in dedicated boxes. They have their web servers in cloud boxes. And they have a smattering of other servers doing different workloads that are part of their application. So you want to have all of that flexibility. You also want to be able to move flexibly between those various architectures. Whenever you first start an application, any technologist knows you can spend weeks and months and years trying to nail exactly what the architecture should be, or you can kind of go with your gut, make a decision very quickly early on, deploy it, and then learn as you go. And this is a much more modern technique. A very enterprise approach is to spend 18 months, nail up the architecture, purchase all the equipment, and hope you got it right. And most of the time you get it right because you spend so much time preparing, but you miss a lot of market opportunity. Companies these days, startup companies, internet companies, they go the opposite end of the spectrum. They don't spend a lot of time planning, they spend more time doing and then adjusting as their workload and their customers demand. So you want to be able to start, perhaps on this previous slide, you want to be able to start with a bunch of dedicated servers because costs are contained and you know what you're getting and you know it's controlled. But then you want to be able to flexibly move into the cloud as that workload goes up. Or perhaps you want to start the other way and it's a complete prototype. You're not sure if it's going to last even 2 weeks. And you just want to put it in the cloud, start it, and see how it goes. You can get a $50 cloud instance and just kind of see how things work. But if it works well, then maybe you want to move some parts of that to a dedicated server. So you want to be able to move back and forth, and this is something that's very difficult to do. We have this thing called a flex image, which allows you to bring image management techniques, just like a cloud instance where you can take a snapshot and auto-deploy that instance over and over again and scale your architecture that way. We can do that on our dedicated instances as well. But perhaps even more importantly, you can take a dedicated server and take your image on that server and deploy it to a cloud instance. And you can move back and forth between the cloud and the dedicated server seamlessly. You just take an image and you deploy it. So a good example of something that an enterprise class company, a service provider, really isn't interested in doing because they're about long-term planning. We're about enabling you to make decisions on the fly and be nimble and agile and adjust to the needs of your application and of your customers. So we've talked about access, being able to have a solid internet into your servers, between your servers, and out from your servers. Having a solid architecture that allows you to flexibly define the architecture, really customize each server in your infrastructure to the workload demands of the layer that you're working with. The third area that we wanted to talk about is ability to execute. Doing all of what I just said from a service provider perspective is very expensive. There's a lot of inventory required. Whenever you request a piece of hardware from me, we turn it up in under 2 hours, even if it's a dedicated box to you. Very often, cloud providers have if they're going to provide you dedicated servers, they don't have that inventory in stock. That's something that you call them. You spend a couple of weeks defining what the architecture will look like, defining what your needs are, then an order is placed for hardware, then it gets delivered and turned up. All of that might take anywhere from 2 to 4 weeks on for a typical provider. We do all of that as soon as you press the go button in our portal. We can turn over any piece of hardware to you that we have in under 2 hours, and we have inventory in all of those data centers that looks the same. So you can get near to your customer with a new database server, a new web head, and anything in between right up to your customer. So you've got to have the inventory online and ready to go. We can't deliver what isn't already there. Secondly, you want to have solid controls. You want good control panels that let you have the ability to execute. So inventory is about me having the ability to execute. Giving you control is about giving you the ability to execute. You want to be able to control your servers and all of the network infrastructure that goes with it seamlessly. You want obviously a web portal, but in addition to web portals, you want to be able to access your servers and the control panels for your servers in any of the devices that you guys have in your pockets right now, the same one that I have up here. iPhones, Android devices, all of these platforms, you want to have the same set of controls available to you across all of those platforms. Maybe more importantly, you want a complete API to allow you to build your own control panels. So we build a lot of those control panels for you, but if you have particular needs, if you have a team that already has a set of tools and you just want to integrate our infrastructure into your control panel, we have a solid API. Everything that you can do in our portal or in any one of our control devices, you can do through our API. So when we deploy a new product, it's immediately controllable and orderable through the API. We have an entire set of websites devoted to forums. We have people devoted to supporting you as developers use our API and train you on the API. So you want to be able to control your servers from your tool sets as much as from my tool set. And lastly, the time element is extremely important. Do you have the product available to you when you need it? Can you turn that server up in under a couple of hours, or does it take weeks to be able to achieve the scale that you need? And what kind of contract are we locking you into? A key element of an internet company is that they live from month to month, from week to week. We don't have any contracts of any kind. We do all of this stuff on a month-to-month basis. We offer dedicated servers and cloud servers on an hourly basis if that's what you need. So you don't want to be locked in to a time element that exceeds your ability to plan as well. So those are the three aspects that you really want to think about from an internet cloud provider. Access, flexible architecture, and ability to execute both on our side as well as giving you the ability to execute. Let's look at two customer examples. A couple of names that you all may recognize who have achieved this sort of scale. The first one is Tumblr. It's one of the largest blogging sites in the world, and many of you probably read it from time to time. Many of you may post blogs out there from time to time. Several years ago, Tumblr was one of our smaller customers. They had, a half dozen servers. They were struggling to get off the ground, like all of the other internet sites. Today, they have over 52 million blogs. Every day, they have over close to 60 million blog posts to get posted. That's an incredible amount of activity that goes on to their servers. All of that is over the web heads. They've got huge database installations. They do tons of analytics on all of that. It's a huge infrastructure that they have. They've been able to scale seamlessly and without issues on our platform. Overall, they have over 20 billion blog posts. An incredible example of internet scale. That's taken place over the course of several years. A separate example, if you guys have heard of the Draw Something game, it came out a while ago. It's been number 1, number 2 on the iTunes for quite a while now. That's by a company called OMG Pop. OMG Pop has been with us for quite some time, and much like the company that I talked about earlier that had a huge pop in their web servers whenever their CEO went on that TV show, OMG Pop had almost overnight instant success. In fact, they did have overnight instant success with their Draw Something game. They went from having tens of servers with us that were fairly stable to needing hundreds and hundreds of servers, and they've been able to achieve all of my kids and all of your kids' drawing needs without any problems and very quick access. So those are just 2 examples. We could go on and on with examples like that. So I want to kind of close just with the sort of walking through the concept again of enterprise class versus internet scale, and to note that it's not the problem that's being solved that's different. Even though the example I gave had 2 really kind of different use cases that they were solving. The big difference, though, is in the approach that you as a customer, whether you're an enterprise or an internet company, or that I as a service provider take, the approach that we take to solving that problem is quite different. An enterprise approach is about long-term planning. It's about trying to know everything up front. And then it's about cost management. I wouldn't say it's about cost savings, but it's cost management, right? It's about knowing what the costs are going to be. Whereas an internet scale approach, a new approach, a true cloud approach is about growing as your needs grow. It's about flexibility. It's about getting out there quickly and being able to change as your needs and your customers' needs demand. It's about being able to say yes and solve problems you weren't able to say yes to yesterday in an enterprise because the costs and the whole business case, maybe it just didn't work. Well, this gives you a whole new suite of tools to be able to solve problems in a way that doesn't lock you into a cost basis. So you can do things for your internal customers in your enterprise using these internet scale techniques that allow you to solve problems that you couldn't solve yesterday. And certainly if you're a startup company, you would be going with an internet approach today from day one. You would never go buy a big colo space and fill it full of gear when you have a small runway of money. That's how these 2 companies that I just walked through really started. But this logic and this approach applies to enterprises just as much as it applies to internet applications. I don't know if we have time for questions. I think I've covered my time.
Yeah, I have a question.
Okay.
It was a great presentation on enterprise and internet scale.
Yes.
As an end user,
yes.
assume I'm the end user. If I'm moving an Oracle enterprise database to a cloud hosting, what is your take on the licensing model and how it works?
Yes. Yeah, so the question is, I'll generalize it and talk about licensing models with a cloud provider. Well, there are really 2 key elements of the licensing. Well, there's a couple of ways to think of a licensing model. In one model, you bring your own licenses. So you're an enterprise, and you have licenses that you've purchased in the past. That really only applies if you're on a dedicated box, and that box is devoted to you. But we do that today. You can bring your own license on our boxes. When you go to an hourly or a cloud instance, a virtualized instance, licensing can get a little bit messier, certainly. With some vendors, we've been able to work through that, and we have hourly licensing available. With other vendors, it's not quite as easy, and they're not willing to move to that model. I think over time, we'll certainly see all vendors come around to having a cloud model where you can license it and license it just for a few hours, not have to license it for an entire month, even if you just want it for a short period of time. A lot of the new internet application infrastructures, Hadoop, MongoDB, Couchbase, they all either natively don't have a license, they're free, or they're natively very attuned to the cloud model and they have an hourly basis.
typically, moving from enterprise license
Yes.
to cloud, is it necessary that we need to change the architecture? Or
It's not necessary, no. You know, there are certainly differences, and it depends on the licensing deal that you struck with your company. You know, sometimes they lock a license to a specific machine. Obviously, that's problematic. But if it's your license and it's on your server that's in our data center, and we can give you the MAC address, you can get the IP address, and you can lock it down to those two things, you know, then that works. It doesn't work in the cloud, though. It doesn't work in a virtualized instance that way.
ladies and gentlemen, if you have any questions.
Okay. Thank you very much.